Hi, this is Nimla Rednam. In this video, we are going to talk about solid shapes. We are dealing with the 9th chapter Mensuration from NCERT textbook class 8. Now, up till now in geometry, we have been dealing with two-dimensional figures, that is plane figures. All the figures that we have studied lie in a two-dimensional plane. Now we are coming to three-dimensional figures, which you need three dimensions, three independent parameters to define it, and these lie in space, three-dimensional space. They are not confined to a plane anymore, right? Now here they have given few figures. These are few examples of three-dimensional solid shapes: cuboid, cylinder, cone, cube, and pyramid. Now you can see that here, if you look at the cuboid, we have certain terminology. For example, all the plane figures that you have that form this particular cuboid, they are called the faces. Okay, they are the faces, and any two faces meet at an edge, right? This is an edge, and any given three edges meet at a vertex, a single point vertex. So these are the terminology you use. And then you have, for example, for a cylinder, you have a curved surface, right? And then it's not a plain surface as you have for a cuboid. For cylinder, cone, you have curved surfaces as well, right? And then we come to something called, we are going to discuss surface area. And as the name suggests, we are talking about area of the surface of the solid shape. And within this, you have lateral surface area and total surface area. Now, what we mean by lateral is, for the given particular solid shape, if I look only at the lateral part of it without considering the base and the top, then it's called lateral surface area. And if you consider those two as well, you get the total surface area. So first let's look at the cube here. This is the simplest form of a solid shape, right? This is a cube. Now this is the simplest form of a solid shape. Now what do you have in a cube? The faces are squares, right? And then you have that means that all the three dimensions, length, breadth and height, are the same. Now we'll talk about something called the net of a given solid shape. Now what we mean by a net is, when I cut it along the edges, certain edges, and open it up, right, I will be able to look at the net of that particular solid shape. Now, how is this useful? Clearly, if I have converted this three-dimensional solid shape into a two-dimensional figure, and finding out the area is going to be very convenient for me, right? Now, this is nothing but net of a cube. As you can see here, this is the net of a cube. Let me show you one more time. So this is how the net of a cube looks like. So what we will be doing is, you will form creases along all these lines and then fold it up. Then you will obtain something like I have just shown. So if you fold it up along these creases, right, you can get a cube, right? So this is nothing but the solid shape cube, right? And now we are interested in the surface area, right? So for the cube, if each side is A, right, and you know that for a square, the area is A square, right? The area of a square is A square. Now this is one square. In that manner, I have 6 squares, each of area A square, right? So the total surface area is going to be 6A square, right? So that's it. That is your total surface area of a cube. You're going to get it as 6A square. Now, if they ask you lateral surface area, it's going to be only 4 of them, which is 4A square, right? So that is for the cube. So let us write it down. For a cube, we have 6A square, right? And lateral will be 4A square. If this is total surface area and this is lateral surface area, right? Now let's come to the cuboid. Now what do I have in a cuboid? As they have shown in the, in the textbook, you're going to have again 6 faces, right? And you will be having a figure something like this, right? The only difference is that each face now is going to be a rectangle. It's not going to be a square, it is going to be a rectangle. So if the dimensions are L, B and H, right? If this is H, then I want to find out the surface area of this using the net of the cuboid, right? So let me uniformly write it everywhere before opening it up for the net, right? So I have L here everywhere, and then if this is B, this is also B, and on the opposite side I have this is also B, right? And then I have this is H, so this is also H, and this happens to be H, this is also H, right? That's it. So now in order to get the net, like we discussed earlier, we will be cutting along certain edges. So I've cut it along this edge, right? And I've cut it along this length, okay? And this particular edges, right? And then I'm going to open it up. So here we have the net of a cuboid, right? This is a cuboid and this is the net of a cuboid. Now here let us try to find the surface area. Now this rectangle, now this is H, right? Because if you can see, this is aligned with this particular length. This is H, so this is also going to be H, right? If you can see, this is H. We have written, that means this is also H, right? So I have LH here, I have LB, and I have LH again, and this is LB again, this is BH, this is again BH. So that's it. All the 6 triangles, I know the areas. Area of a triangle is length into breadth. So given the dimensions, I can find the area. Now when I add this up, okay, you have 2 LH, 2 LB and 2 BH, right? So I'm going to get, for a cuboid, 2 times of LB plus BH plus LH. Now, lateral surface area, it depends on how the orientation of your cuboid is. For example, if this is the orientation of your cuboid, right, that is, you're taking the base as LB, okay, whatever is your base and top, that has to be excluded. So if your base is LB, then it is going to be, if the base is LB, then it is going to be 2H into L plus B, right? The lateral surface area, because this I'm going to be excluding. If the base is LH, okay, if my base is LH or HL, then it is going to be, I have to exclude that. So 2B into L plus H. And if my base is BH, if this is the base, that is, this is the cuboid I'm talking about, okay, then I'll be excluding the base and the top, and I will have 2L into B plus H, right? So that is how the lateral surface area is going to vary depending on the orientation of your cuboid. The only reason we are discussing at such length here is that there are questions in the exercise where you have to understand what is the lateral surface area of the given figure depending on how the orientation of the cuboid shaped, whatever, if it's a classroom or anything that they have mentioned, what is the corresponding to that particular sum, you have to decide what the lateral surface area is, right? So that is about the surface area of a cuboid. Next we come to the cylinder. So what do we have in a cylinder? So here I have a cylinder. We are talking a special case of a cylinder, that is a right circular cylinder. Right implies that the axis of the cylinder, which is the line joining the center of the top and the center of the bottom, is at right angles to the base or the top, and circular because the base and top are circles, and it's a cylinder, right? So that is about a right circular cylinder, the special case that we are considering. So if you look at the cylinder here, in order to find the surface area, again we are going to look at the net. How do you get net of a cylinder? You cut along the, you're going to cut along the circumference of the circle for the top and the bottom, right? And then you're going to have two circles here, right? And then you will make a cut along the axis, right? Along the axis, if you make a cut and open it up, you're going to get a rectangle. You'll be getting a rectangle. So this is the net of a cylinder. You can change the orientation. So this is the net of a cylinder, right? Now here you can see that all these figures are familiar to us, and you can quickly write down the surface area of this. Now for the circles, it's very easy. If the radius is r, then the circumference is, if the radius is r, the area is pi r square. So I've written it here. That's the area of the bottom and the top. Now coming to this rectangle, we are very familiar with the area of a rectangle. But what are these dimensions? Now this is height of the cylinder edge. What about this? Now you can see that this is nothing but the circumference of this circle. So while cutting, you've seen that you have cut along the circumference of the circle in order to open this up, right? That means that this entire length is nothing but 2 pi r. So this rectangle is going to be 2 pi r h. So that's it. I have 2 pi r squares and 2 pi r h. When I add these up, I'm going to get the area of the cylinder. So for the cylinder, it's going to be 2 pi r into r plus h. So this is my total surface area. When it comes to lateral surface area, I'm going to disregard the base and the top, which will give me 2 pi r h. So these are the formulae for the surface areas of these three solid shapes. In the next video, we will look at the solved examples, try these questions, and think, discuss, and write sections of exercise 9.2.